Okay, recording's on. Thanks everybody for volunteering to show up for an incredibly exciting lecture about storage. I do rail about this a lot in class. There's been something of a revolution in the last 5 to 8 years of spinning drives to solid state, and it has frustrated me how some computer makers are still pushing spinning drives even after they're proven to be worse in every way. So, if I get a little emotional and sound more than slightly bitter, I apologize in advance, but I feel pretty strongly about this. It's in a nerdy profession, you get to choose your hills to die on, and solid state drives are one of mine. So, we're going to talk about various types of storage, how it's changed over the years. The quiz should be unlocked, and then we'll get out of here. Tomorrow and Wednesday, I'll try to Discord stream both labs, and we will be, I'll probably Discord stream Wednesday because we're having like an audit tomorrow. But I may do it anyway, just so you guys can observe if you want. But we're going to probably take off processor coolers and processors if people are quick enough, comfortable enough with it on our junky computers, and put them back together and make sure they work. It'll be very exciting, and it's an important step in your ability to rip apart computers and put them back together. So storage, with reference to hard drives, we're starting with this idea. We're going to remember that in the technology world, every time we invent a thing, we invent something better shortly thereafter and kind of leave it behind. And so you have to stay with the times. You have to change. You have to modify yourself. You have to keep up. And it started with the spinning hard drive, which for its time had incredible features, and it stored an amazing amount of information. The revolution in the 90s and 2000s was amazing amounts of space on a spinning hard drive. It blew our minds to hold 100 gigs or 300 gigs or 500 gigs on a single drive, and that changed computing. It changed video games, certainly, because now video games were like, well, we can just go crazy on image quality, on textures, on audio quality, on cinematics we include in the game, because before games there were two problems with making gigantic video games. One was, how do you get it to the customer, because it wouldn't fit on a DVD or a Blu-ray or any optical media. And two was, how would they store it? It would just dominate the space on their computer when they had 20 and 30 and 50 gig hard drives. Well, hard drives got bigger and the internet got faster. So suddenly video games stopped being a thing you bought like a DVD and started being a thing you downloaded. And movies and TV have now followed that. So the spinning hard drive was really important to that kind of information data revolution. And it worked with a bunch of spinning disks, metal disks. Every little tiny piece of metal in here could be magnetized or not. That was your ones and zeros. It spun. This needle read it. This actuator arm moved it. And the faster it spun, the faster the arm moved, the faster you got your files when you wanted them. Firmware controls read and write. So we judge these by read and write speed. Reading means pulling information off of the hard drive, and writing means putting it on. That's it. That's all read-write means. And datas were organized in kind of circles on here. Not too concerned about this data. This will probably be the last year of teaching hardware that we talk very much about spinners and about optical media. We'll still talk about them in the historical sense, but they're going the way of the dodo. And we don't know what's next, but someday solid states will get replaced with new technology also. Typically, your laptop drives rotate at 5,400 RPMs. This is less vibration, less power required, less heat generated, less noise. That's why they're laptop drives. 7,200 is what you find in most desktops that have a spinner. That's just the speed that they're conventionally set at. And then in servers, or if you spend extra money because you want a slow hard drive to go as fast as a slow hard drive can go, you would buy a 10,000 RPM spinner. Pretty much any drive you ever see is going to go one of those speeds if it's a spinner. And compared to modern equipment, they are pretty terrible. But again, for their time, they were great. And the way it works is there's multiple platters, which have multiple sides, and this spindle is what they're all sitting on, and the platters rotate, and the head reads the data or writes it to it by moving around, and this actuator moves it back and forth. That's the basic principle. It's very similar to a turntable that you would play a record on. Almost identical, in fact. If you hold them up next to each other, you can just clearly see this is the same kind of idea, although this one is scanning sort of ridges and shapes cut into the vinyl, and this one is actually pulling up magnetized or unmagnetized sections. We'll see later that optical media uses the same principle. We were stuck on this for a while. It went from records to CDs to hard drives, and now we're kind of done with it. And I had a lot of fun making this slide. It's not really very pertinent, but you get the idea. Never put sounds in your PowerPoint. That's tacky. So this is a detailed diagram of the way the data is stored on a spinning drive. You can see here is the head, here's the actuator arm, this is the spinning disk, okay? And it is organized into sectors on the platter. And when these things started to die, when they started to break, you would get warnings that said bad sector. And that meant that one of these areas was no longer readable or writable, possibly. Maybe it was one or the other, but not both. And so it became useless. And the drive would sort of never use that space again. But of course, that means the drive gets smaller and smaller. And if it developed one of those due to physical trauma or some other problem, heat, demagnetization, whatever caused it, it was going to happen to the rest of it. So as soon as you had one bad sector, you typically knew that drive was going to fail you. Also, they'd start making funny noises if the actuator arm ever got goofed up. Lots of weird clicking and rattling, and they just couldn't work anymore. But they made noise, so that was kind of helpful. You could troubleshoot them that way. So solid-state drives were very different. No moving parts, no spinning anything. And initially, they were limited. They were very limited, and they didn't catch on right away because you could only read and write to them so many times. Like if you could only save your homework to this thing 100 times and then load your homework off of it, it wasn't particularly useful at that rate. Then it became 1,000 read writes, then it became 50,000, then it became so many that you don't really think about it anymore. Probably you're going to get a new computer before your drive runs out of read writes. They were, at their launch, very expensive. They have always been, though, even when they were kind of crappy, they were still fast. There's no spinning, there's no actuator arm moving, no needle to move, so the data just kind of shoots right off. It goes as fast as the SATA connection can carry it, and that's what they mostly had, is this is a SATA connection. So because there were no moving parts, you could drop them, they could suffer some bumps and bruises, and they would not lose data. They were, in fact, more reliable. They did not generate much heat, no moving parts. They could tolerate kind of more extremes of temperature and environment, and they used less electricity. They were just better once we solved this read-write problem. And it wasn't just SATA drives. It was also SD cards. Took the camera world by storm. Either little teeny guys, like your phone SIM cards are a very similar device, or big ones like this that fit in your camera. And this allowed you to take very much improved photos. Most pro photographers I know these days are digital. And they use, obviously, much larger cards than this. They're up to like 256 gig cards and larger, that allow them to just snap incredibly high-res photos all day and then pull this, go plug it into a computer, and download everything from it. We don't go too far down the path of detail on things like this, but it's good for you to understand that a flash, like a solid-state card or an SD card like this, is very much like a motherboard, like a memory board. Like, see, here's where the data is actually stored, and then we have a controller chip that keeps track of where everything goes to and comes from. And then it talks to the SATA interface, which provides that data to the computer. So maybe Windows 10 is kind of stored over on these chips. Maybe your Microsoft Word's over here. Maybe your video games are over here. The controller knows where everything is, and it retrieves the data. Okay? Okay. Same technology, flash drives, pen drives, thumb drives. They have many names, but usually they are USB. And this is awesome because they get both their data, read write, and their power from this. So you just plug them in and suddenly the drive is on the desktop. The drive is accessible. If you use formats FAT and exFAT, both Macs and PCs can read them. Or if you use NTFS, only Windows can write to them. Macs can still read it. And then Macs has their own format that Windows won't read or write at all. And of course, as we demonstrated in our lab last week, you can boot your computer with these and install this. You could turn one of these into a Windows 10 installer and have a junk computer that didn't work and had no operating system. You boot the computer from the flash drive, and then it installs Windows 10. We also did this with Linux. You can also do Linux Live and just boot from this and pretend it's your computer hard drive. So these are very versatile. You okay, Dan? Okay.
Yes. Yeah, I'm good.
Okay, good.
Sorry, I had my son playing Star Wars next to me, so I just had to stand in on mute.
Oh, what Star Wars is he playing?
Battlefront, the first one, I think.
Cool. I think we played that one. Next in the sort of line of drives, we decided that SATA drives were too slow. We decided that spinners were too slow, and we ditched all this and went on to, or tried to go on to, mSATA, which was still technically SATA, but it had a little slot on the motherboard near the processor. And you're like, well, we'll just build the hard drive into a chip. You put the chip in the motherboard, and that didn't catch on. Nobody liked it, and everybody fought about how big it was. But then several different companies agreed, okay, we'll go with a slightly longer shape. We'll call it M.2. It's version 2 of mini SATA. And we're all going to build to the same form factor and be compatible with each other so that we can compete, but so we can exist on the same motherboards. And this has caught on. Most of the new Dells that were bought this year for John A. Logan and for SIU are going to have M.2. They will have this type of hard drive already on the motherboard, already with Windows 10 on it. That's how Dell is shipping computers now. Okay. This is pretty well true for all hard drives. A low-level format. A hard drive, all of your information is really just a collection of ones and zeros. A certain sequence of ones means you got Microsoft Word. Another sequence of ones and zeros means this PowerPoint. Everything is just a giant string of data. So if you came along and reduced every single sector on a hard drive to zero, you would have erased it to a complete level. Files absolutely gone, nothing left. This restores it to its original factory condition. It's called a low-level format. And after someone's done using a computer, we usually do a low-level format, sometimes several of them, because we want to make sure we get all their data off to protect their data, especially if it's sensitive. If you're working at a law firm, every old hard drive, a partner retires or a secretary or paralegal, somebody leaves, and you're going to prep that computer for somebody else, you back up the files that the firm needs, and then you do a low-level format. If you are selling the machine or junking it, sending it on to recycling, donating it to Rob Craig's ELT program, you need to do a multiple low-level format to make sure the data is gone. It's something of a funny scandal that in our section 1, Wendell's test computer that he's working with this semester has a hard drive in it. The hard drive works, and it has a working operating system. The operating system has the password saved. So when Wendell boots up his little junky PC, it dumps him straight onto the desktop, and there's some files there. And these were donated from a bank. Now, most likely the IT guys are aware of this. It's not a big deal. It just looks like it's worrisome, and there's no actual data on there. Most places like that are storing all of their workers' data in the cloud, which we're going to talk about in a bit. And so there's nothing on that hard drive. But before we get rid of anything at SIU, and I think this is true for John A. too, when we're done with the computer and we want to get rid of it, we have to low-level format it. Now, if it's just your home computer, you can do the quick format. You can do a high-level format. A good example of this is my computer's goofed up. It's really slow. I'm going to reinstall my operating system. I'm going to reinstall Windows, Mac, Linux, whatever it is. Doesn't matter. I erase the computer as quickly as possible. I reinstall Windows, and the computer behaves quickly again. But I didn't do a low-level format. When you don't do a low-level format, technically all that old data is still there. It's just being kind of ignored by the new data, and the new data might write over the top of it. So every sector has an address and a size, and the drive knows the total number of sectors. Now, spinners developed a technology called SMART. I don't remember what it stands for. It kind of doesn't matter because it was very unreliable. The problem was spinners all fail eventually, pretty much. Their manufacturing process is based on how likely they are to fail and how long they are likely to go before they fail. So this sort of planned failure is why they added smart status. It's a bunch of little checkups that are run on the drive, and it warns the operating system when it thinks the drive is going to fail. By the time it warns you, you have probably already lost data. So this is not super helpful. Like you usually, in my experience, you know well ahead of smart when a drive is going to fail. So it didn't prove to be that useful. As far as the speed comparison, it's very measurable. Access time means you double click a file. How long does it take before the drive responds and tries to open it? You got 5 milliseconds for a spinner and 0.1 for a SSD. So we're watching this happen in the automobile world right now. Does anybody know much about, either of you know much about electric cars? Hello, Daniel. Welcome to the channel, Daniel. Are you ready to answer a question?
All right.
Which accelerates faster, a gas engine car or an electric car?
I would say gas.
Okay. In the case of like a cheap, low cost, like a little Nissan Sentra versus an electric car, the Nissan Sentra loses. In the case of something big like a Corvette or a Mustang versus a similarly priced Tesla, even the family sedan Tesla, the Tesla wins most of the time, hands down. The electric vehicle and the electric motors have no delay to their acceleration. Like a conventional motor has a power band, meaning it's most powerful in a certain range of RPMs. This is also true of spinning hard drives. Their optimal speed has to be achieved, but not SSDs. They're always ready to go at full speed in an instant. So I'm into cars and I'm into computers, and I'm sort of watching these two revolutions happen in kind of exactly the same way. I drive a gas engine sports car and it goes fast and I like it. And the Tesla soccer mom mobile is faster than my car. That makes me sad, but it also makes me want a Tesla. So when we look at reliability, the SSD is also better. The energy cost is lower. They don't take as much power. This means because they're so quick and because they don't really need much I/O handling, they do it on their own. The CPU has to pay less attention to a solid state drive than it does to a spinner. And so input output request times are lower and backup rates are obviously much quicker because of the write speed. And the interesting thing is, if you compare this to M.2s, they're even faster. So to interpret this is a wall of numbers. It's a little intimidating, but let's start here. This is a Western Digital 7200 RPM drive. This is the spinner up here, the top left. Okay. To the right of it is a Samsung 950 EVO 1 terabyte. This is a very nice solid state drive. This is a $150 or $200 hard drive. And right here, read megabytes per second, 100, 102 to 557. The solid state is much faster. It's at least 5 times faster at this particular test. Then you look at some other file sizes, some other comparisons, And the solid state in some cases is dramatically better, well beyond. We sort of average all of this and say that the solid state is 25 times faster than the regular one. That's just the math they worked out, averaging all of these differences. But you can see it's huge on bigger files, especially. You're looking at writing, like to save this giant file onto the spinner, you're going 2 megabytes per second. If you're on the solid state, yeah, you're at 170 times that speed. It's huge. It's a giant difference. And then, to be fair,
Man, that's gonna change the game. Like,
look at M.2s. Have you ever used a computer with an M.2 drive?
no, I honestly hadn't even heard of it until I heard you ranting about it in class one day.
Ranting is fair. No, go ahead and tell the truth. From working
There
with
was a
these
series
things,
of swear words with no other language in between, just to express the magnitude of difference between them.
I'm sure you've misremembered the swear words. This is a recording that the dean might see, and I'm being audited this week, so I'm sure that I said "gosh darn dang."
Yeah, this is a hypothetical scenario. I was
Diggly,
running.
super smelly spinners is probably what I said. So to continue this comparison, though, like we just got a bunch of these solid state drives, regular SATAs, for G102. And currently the machines in there are i7 processors, which is great. They're 8 gigs of RAM, which is good. And they have okay monitors. The mice and keyboard are cheap but reliable. So the computers in there are okay, but they have these hard drives. I'm almost certain they have Western Digitals too. This is a decent, for a spinner, this is a good hard drive. And Rob and I, thanks to Dustin, appreciate you, Dustin, we got a bunch of these from John A. Logan IT. And we're going to put these in there, and those computers in G102 are going to be this much faster. And then hopefully someday, or wherever John A. Logan's getting new computers, because every year they're going to get a certain number of new computers. They don't have enough money to replace all the computers at John A. every year, so they have it on a cycle. Most likely every computer on John A. Logan gets to 5 or 6 years, and then they're like, okay, you're too old. Bye-bye, we're going to get a new one and send this one on to somewhere else. But if you look, a good solid state can open up your file, can load your video game, can boot Windows at 550 megabytes per second. And the M.2 can do 2,500, 5 times that.
That's crazy.
Yep. And you do notice it. And if you do this for your customers, like if you have a customer come to you and say, my computer's slow, that happens all the time, by the way. There's a lot of things you can do to make someone's computer faster. Sometimes they've got a bunch of junkware, malware weighing them down. Sometimes they've downloaded too many video games or other things and the hard drive is full. But sometimes you just go, well, you've got a spinning drive, and if you give me $50, we'll put you on a solid state. And they will notice a difference because Windows will start up a lot faster. Their programs will open faster. Go ahead.
Is the storage space also like massively larger, or is it just faster?
You pay for the space. The cost per gigabyte is the way we measure it. And spinners are still the cheapest because they're the slowest. So your cost per gigabyte of a spinner, like this drive right here, this is 2 terabytes. Okay. This guy is, well, let's just look at it real quick. We go like this. Go over to Amazon or wherever. 2 terabyte Western Digital 7200 RPM. How much does that hard drive cost right now? $100, right? For a 2 terabyte Western Digital 7200 RPM. This is about as nice a spinner as you can get. So then we go Samsung 950 Evo, 1 terabyte, half the size, almost twice the cost. Well, that's the M.2. Where's the SATA? Here we go. Nope, that's okay. This is fair. If you got a solid state in the same size as this spinner, it would be almost 3 times as much. But it would be a lot faster. And then if your computer supports M.2, this is obviously the guy to get. Because look at him. This is a 1 terabyte drive, half as much space as this one, equal to this one. And it has, $179. So $79 difference, twice as much, but you're getting so much more speed. You're going from here to here. It's huge. But not every computer has this slot. They don't all have that option. They can all take this, though. If it has a spinner in there, you can put that in there. Let's see. Where's the actual? Here it is. Yeah, see, 196. These are being manufactured less, so their cost is actually going up. They had dropped below this. Things in the computer world are, there's two things that make a thing, an item or an upgrade or anything you purchase, cheap or expensive. One is how new and how good it is, like you expect, the quality of it. It's a new fast hard drive, so you figure it's going to be expensive. But then the other thing is, how many are they making? If they sell 100,000 of these per year, it will be more expensive than if they sell 1 million of these per year. Because the more they make, the less they make them for. That's just the way manufacturing works on stuff like this. So yeah, totally worth it to get the M.2 if the machine has the spot. And I can tell you, last year I took my gaming PC from regular SATA SSD to M.2, and I did notice a difference. Windows does open quicker. Video games open quicker. Photoshop is quicker. Messing around with my PowerPoints is quicker because I have a lot of graphics. So it's just better. You guys have any other questions about solid state? Okay. It really is a great way to look like a hero to your customer. Your customer, your aunt, your mom, your family, your business down the street that you're friends with says, my computer's slow. What do I do? And you get them a solid state drive. You help them copy over their data, and they will love you forever and think you're a wizard. They will literally say you're a wizard, Harry, because you will just make their computer so much faster for so cheap.
I might just put in a solid state drive for a customer today.
Did you?
Yes, I did.
What kind did you put in?
I put in a Kingston 480.
That's a really affordable drive. I've used those.
It is. It's like $50, if that.
There you go.
Yeah.
46. Yep. So how big was their old drive?
2 terabytes.
And they didn't mind coming down to 25% of the space because they weren't using it, right?
They only used 86 gigs of that 2 terabyte drive.
That's what you will find a lot of the time, is that they probably bought a huge hard drive when they first bought their computer because it was advertised. And the general public does not understand this. They want a fast computer that they can get lots of work done on. But they think that bigger numbers means more speed. So
they think the RAM is what makes it faster.
That too. But it all matters. So they look and they say, oh, this has a 2 terabyte hard drive, whereas this one only has 0.5. It has a 500. And they're standing in Best Buy, and the turd burglar at Best Buy goes, yeah, this one has 2,000s and that one only has 500. Never mind that the 500 is one of these and it's far faster. And also never mind that they don't need 2 terabytes of space. I don't know anybody who needs 2 terabytes of space unless they're a video editor. Nobody does. That's great. I bet they're happy.
They were surprised in the difference in speed.
That's the best part, is the surprise. People don't expect it to make that much of a difference, but I've done this for accountants and other just basic computer users, and they love you. It's a huge difference. Another good difference in computers these days is they typically don't have optical drives anymore. Does anybody still watch Blu-rays?
No, I do not.
The movie industry is still
the DVD.
Yeah, this is all just basically evolution of the compact disc, right? When I was a kid, it was albums when I was a really little kid. And then for most of my teenage years, it was CDs were the thing. And then it became downloading music services. Nowadays, I'm on Spotify like everybody. And so I don't really use this stuff anymore, which is why probably fall 2021, these questions won't be on the test anymore. I kind of think they shouldn't be now, but I'm leaving them in because if any of you do the certification at the end of the semester, I bet they'll still have the optical media questions on the CompTIA cert. because it's a gigantic test and it's a lot of effort for them to update stuff. So just remember that CDs were 1 layer, DVD used 2 layers and 2 sides, and then Blu-rays did the same thing but better, stored the data in smarter ways and managed to cram more on there. Okay. Now, SATA is how most of the hard drives you've ever used are connected, even whether they be spinners, solid states, your CD drive in your average Dell or HP PC is probably SATA connected. Stands for Serial Advanced. It's a serial connection. That's important to know. You don't have to remember this acronym, but remember it's serial. That's just the type of connection. This is the next evolution of the serial drive. And again, we're kind of abandoning it. We're moving to M.2, just bolting things straight onto the motherboard. SATA has 2 connectors per drive. So on the back of that hard drive, there's a really wide connector that you can't put in wrong because it has a funny little elbow on one end. You can only put it in one way, like a USB port. This is power. The big one is power. The little one is data. And you got to connect them both or the drive won't be doing you any good. You can see this is a spinner. This is 3.5. And so you connect both of these connectors or you don't really get anywhere. And see, SATA standards have, of course, changed over the years. When we first started using it, it went about this fast, 1.5. And then we got it up to 6 gig and we've kind of stopped there. And it's this halt. Like SATA was improving. And then we got to version 3, SATA 600, and it's going 6 gigs a second. And this is in 2009. So here we are in 2020, still using a 10-year-old standard that has not improved much beyond this. That's why we're abandoning to M.2. That's the bottleneck. It became the bottleneck, so we had to abandon it. Now, external drives are convenient. I advise you steer your customers away from them. Customers tend to think that if they back up on an external drive, they're totally safe, but they don't really think about what if a fire claims both these items? What if both these items are in your backpack when it's stolen? What if both these items are in the same building when there's a flood or theft or fire? What if you live somewhere with earthquake? Basically, they move the data a couple inches away, and people rarely move the external drive anywhere else. So this is not a good backup. It's still good for moving huge files from point A to point B. You want to bring a game over to your friend's house, or movie files, or video editing, or a lot of musicians I know, when they do studio recordings, they travel around with a drive like this, but they're going to little thumb drives on their keychains. The musicians I know that are studio musicians in Nashville just walk around with a flash drive on their keys that stores anything they want to record or anything they've recently recorded that they want to show off. So not so useful anymore, but they're very easy. Typically, they get all their power from USB, even though inside here is a SATA connection. They're pretty cheap these days because they're getting obsolete. Some of them connect with Ethernet. Some of them can sit on a network and be shared. Some of them connect via eSATA. Those are very rare. And again, they all typically use SATA inside. So they're stuck at that 6 gigs. Now, the book and the CompTIA certification will spend some time on RAID, so we don't want to ignore it. But RAID is a redundant array of inexpensive disks. The idea is that you take 20 hard drives and tie them all together and store stuff on them. And any one of them can die and the others still have a copy of everything. So it's good, but we don't usually do this on site anymore because the cloud does it for us. The cloud is probably a giant server full of hard drives in RAID in a RAID setup. And so you just don't want to think about this. You kind of outsource this. But we used to. 10 years ago, if you were hired by a doctor's office, a school, a police station, anywhere you were hired to be an IT guy, you were going to set up a server. You were going to put the hard drives on RAID so there was no way you could ever lose their data. And then you were going to set up like a backup routine to some offsite location. Nowadays, it's just backup in the cloud, make sure everything's encrypted. Let the cloud service worry about the backups. Let them worry about the hard drive failure. But again, it's good to know and understand the basics of it. Now, cloud, when I talk about cloud, I mean anything that stores your stuff on someone else's computer. So Box.net I store a bunch of stuff in there. and they back it up for me. They let me view it from my phone or any computer I log into. Same with Google Drive. Apple does it with iCloud. Dropbox is very popular because it's easy to use. Microsoft has OneDrive, which you're allowed to use through John A. SkyDrive, I think, is what it used to be called. And what is this stuff? Well, it's really a giant pile of servers in the center. And those servers have some storage. They're connected to the network. They have a database to keep track of everything that's on them. They might be a communication server like Facebook or Twitter servers, or a chat server, or Microsoft Teams. There might be a finance server that's doing stock trades like E-Trade or something like that. There might be collaboration like Google Calendar. They could be monitoring like Google NetStats, Google Analytics for your website. But really what they mean is a bunch of servers so you don't have to have servers in your house or in your business or at your law firm or at your doctor's office or at your Chuck E. Cheese. And then you just access your data from wherever you are, on your tablet, your phone, whatever. This makes much more sense. And this is the model that virtually everybody's going to, because the internet is getting faster, which used to be the downside to this. And these services are getting cheaper, which was the other downside, but they're very cheap now. Dropbox is like a terabyte for $100 a year. Google's a little better than that, I think. So this is what we're going to. Can you guys think of cloud services that you already use and rely on? What's an example?
Carbonite.
What's Carbonite?
Carbonite is a cloud backup service. I might use it for work a lot. A lot of my clients use it, but it's just a cloud backup. It backs up all their.
That's great.
You install the client, and
Yeah.
it just backs up the user folder, and then you tell it what else to back up.
So
I'm
you don't.
excluded from that.
So with that installed, you don't have to use external hard drives. You don't do
Nope.
local backups. You just trust that.
Yep.
Then if someone's computer dies, you can log in their Carbonite to another station and download everything, right?
Yep. It has versioning as well.
Oh, that's awesome. That's awesome. Yeah, Dropbox has versioning, which is what, and versioning is when a person wants to get a version of a file. Like, say, I had somebody write a book. They had written like 9 chapters, and they were on Dropbox, and they told me that yesterday I had a hard day of writing. It didn't go very well, and I hated everything I did. And I told Dropbox to just revert my book to yesterday's version, and they did it. And I went, and that helped you? They're like, yes. I just threw away an entire day of writing with one click. And it was powerful. It felt awesome, and I'm redoing it. So I don't understand what it's like to write a book, but apparently that feature's nice for that. And then with you guys, it can be, oh, this version of the file's corrupted, or so-and-so's database is goofed up, or we think someone made a mistake, or so-and-so's ex-boyfriend got mad and destroyed this, and we can go back to whatever version we want, right?
Yep, and for a personal license, which is unlimited storage, is like $74 a year.
That's pretty cheap. That's very competitive. So this is where you are in the IT world. When someone asks you, how can I improve the IT safety of my business? How can I'm a dentist's office, and how do I improve the safety of my office? Well, check to see if they're backing up to the cloud. Check to see if that backup is secured with good passwords, 2-factor authentication, etc. Check to see if all their data of protected files is encrypted. Being familiar with and understanding the cloud, and like Daniel understands Carbonite, you could go to another business who then comes to Daniel and says, what do we do about this? How do we back up? And he goes, I'm so familiar with Carbonite, I can walk in here. And how long would it take you to set up Carbonite on 5 computers, say?
About 30 minutes.
Same. You walk in there, you stretch that out to an hour and go, that'll be $100, and I will have your entire business backing up constantly, and you'll sleep better at night. And if there ever is a tragedy, if all your computers are stolen, or you have a fire or water damage or whatever, you will not lose your data. You can make an insurance claim on a computer, but you can't really make an insurance claim on all your patients' files. But Carbonite can save you. So that's great. That's very smart.
The only issue with Carbonite is it's kind of a resource hog.
Is it?
I will say that. It really is. It's more network, but It's
That's a downside. I know
it
that
is a downside.
you don't really notice a performance hit from Dropbox other than when you first set it up, of course. If there's a ton of data when you first turn it on, it's going to spend a long time backing up the first time. Then after that, it only backs up whatever's changed. So they can probably improve that, though. Maybe over time, Carbonite will kind of program their way around that, optimize a little bit. Okay, so some things that the book wants you to know. When you have hard drive problems during boot, most of these I agree with. If your machine's not detecting its storage, you can unplug and reattach everything. Sometimes that helps. What this really does is tell you if any cable's loose and it's not really connected. You fully disconnect it, reconnect it. If using RAID or any other fancy stuff, remove and reseat that. Reseat, whenever you see reseat, they mean take the card out and put it back in. Because when you slide it into the socket and it locks into place, we call that like seating, like sitting down in a seat. So reseating cards can help a lot. You can inspect for damage if there's been a lightning storm or a power surge, if you smell burnt plastic, if you ever see even a wisp of smoke, you should look at your stuff. Sometimes it can actually be visible. There can be a little burn mark on the PCB, on the motherboard. Spinning drives, I do kind of miss this about them. I don't really miss much, but you could tell by listening to them if they were doing anything. You would hear a little clicking, kind of grinding sound, and when they started to go bad, they would get caught in little loops of repetitive clicks. It would sound like a drum beat or something. Check cable for frayed edges. Sounds more like a rodent problem than anything. Most of these cables should not ever be in an area where they could be worn down or physically damaged like that. Check the installation manual. That's never helped me in my entire career. Neither has smart errors, but definitely if you ever saw a smart error on a solid state drive or a spinning drive, you would know that it was soon about to die. Okay. So the quiz should be open for you guys. Do you have any more questions about storage?
I do not.
Well,
Negative.
okay. Thank you for being here, Simran.
Thank you.
And take the quiz whenever you're ready. Next week, I'm going to open up an exam. Remember, the quizzes are not worth a lot of points. They're worth a little. They mostly help me judge how well you are learning the information. And they are there to help you because the quiz questions either get straight copied to the exam or a very similar version. Sometimes I reword them, sometimes I shuffle some things around, but they're largely from the CompTIA certification exam. And I want you to get used to answering the way they word things, which can be tricky. Sometimes they word things in a way that leads you to the wrong answer. So I don't love doing that to you guys, but if you're going to pass that certification, I don't want it to be the first time you see trick questions. So please take the quizzes and hope to see you guys in lab or on Discord. And thanks very much.
Thank you.
Thanks.